You won't understand at first why we're doing what we're doing, but this is going to lead to an equation of non-homogeneous first-order linear equations. Don't need to see the connection now. Let's just do what it says. Let's multiply y prime plus ty by e to the t squared over 2. Well, we get e to the t squared over 2 y prime plus t e to the t squared over 2 times y. Very straightforward. Now, let's take the derivative with respect to t of e to the t squared over 2 times y. Now this derivative, we have a product of two functions, so our derivative is going to be the derivative of e to the t squared over 2 times y plus e to the t squared over 2 times y prime. Now what's the derivative of e to the t squared over 2? Well, that's t e to the t squared over 2. And this term is just, as it reads, e to the t squared over 2 times y prime. Now, we notice that the derivative of this expression here is identical, except for the order in which the terms have been written, to what we get when we multiply this expression by e to the t squared over 2. Now that's going to turn out to be a big deal, as you'll see shortly. So the question now is, what good is this? Okay, well, the answer to that is, if we have the equation y prime, and I'm sorry, that's not the equation. Okay, y prime plus ty is e to the t squared over 2 times y prime. If we had the equation y prime plus ty equals any function, let's just call it g of t for right now, this means that this side is the derivative of this function, so that this says that e to the t squared over 2 times y prime equals g of t, which means, well, we can integrate both sides of this function. Let me change colors and put an integral sign in front. If we integrate this with respect to t, and I don't really have room to put my dt in there, but I'm going to do it anyhow because it's a good idea. Okay, if I integrate this with respect to t, then by the fundamental theorem of calculus, this integral is just e to the t squared over 2 times y, and the right hand side remains integral g of t dt. Now that's actually quite a big deal, because what we're trying to do, if we're trying to solve this equation, we're trying to find the y function, and the y function is just then e to the negative t squared over 2 times the integral of g of t dt. If we can do this integral, if this function is something we can integrate with respect to t, we've just solved the equation. And we solve the equation by using this trick. Now we're going to solve another equation using a similar trick.